Hello students, Ms. Slyman here. With this set of notes, we're beginning our calculus option, and we're starting with roles and mean value theorem. So we looked at this doing our Desmos activity, but now let's look at formal definitions and some applications. So first of all, differentiable functions. If a function is differentiable at a certain point, then that limit as x approaches that point must exist. So really what that means is that our left limit has to be equal to our right limit. This one's the right limit, this one's the left limit. If I'm looking at a graph, then I can see non-differentiable equations by sharp points, like in absolute values, or vertical tangents. So I have examples of each of those here. The cube root of x minus 1, this graph looks like this. Let me put in a quick sketch here. So here's some axes at x equals 1. What this graph looks like is something like cube root of negative 1 is negative 1, and it goes vertically up. So at this point, I have a vertical tangent. So using my limits, I can say the limit as h goes to 0 at x equals 1, that's going to be f of 1 plus h minus f of 1, divide by h. So f of 1 plus h, that's going to give me cube root of h. F of 1 is going to be 0, divide by h. So limit as h goes to 0 is going to be cube root of h over h. This ends up being the limit as h goes to 0 of 1 over h to the 2/3. And this ends up being infinity, therefore the limit does not exist. So it's not differentiable at this point. Now I've got my absolute value graph. So if we think about this, we know that this looks like a V, essentially. So let's put in our graph. Okay, let's use our limit definitions. So I'll have the limit as h goes to 0, f of my x now is 0, so 0 plus h minus f of 0 over h. Well, this ends up giving me the limit as h goes to 0 of absolute value of h over h. But if I approach this going to 0 from the left, then that limit ends up being negative 1. Sorry, negative 1. And if I approach it from the right, then I end up with positive 1. So these two limits do not equal each other. So h goes to 0 from the left of my quantity. Cheat a little bit. Does not equal the limit as h goes to 0 from the right of my quantity. Therefore, not differentiable at that point.